Hi all, this problem is intended to help with number 22 in section 3.7, and what they do in this problem is they give you a velocity function with respect to temperature, but then they tell you that the temperature is equal to 300 times the pressure P. So what I need to do with this problem is go in and say, well, okay, I'm supposed to find the derivative of the velocity with respect to pressure such that the pressure, or P in this problem, is equal to T. Well, we can't evaluate the derivative of V with respect to pressure if we don't have V in terms of P in the first place. So that's my number one goal, is I need to get my original function in terms of P. But that's easy to do because they tell you that the temperature is equal to 300 P. So all I have to do is substitute that into the place of T in my problem. And then notice now the velocity is not given in terms of the temperature, but the velocity is given in terms of the pressure. So this enables me to be able to take the derivative, and I can find V prime of T, or otherwise known as dV dP. And in this case, on the right hand side, I'm just thinking of this as 300p to the 1/2 power. So when I bring that 1/2 down in front, and I get 23 over 2 times the group 300p to the negative 1/2 power times the derivative of the inside. And the derivative of the inside with respect to p is just 300. So then what I did from there is I just said, well, 300 divided by 2 is 150. 150 times 23 is 3,450, and then I divided by the square root of 300p, since that was a negative 1/2. Now that's my final derivative answer. The goal of this problem was just to evaluate that derivative such that p is equal to 2. So I go into my problem and I can say, well, dV dP such that p is equal to 2. I'll plug that in here and say I'll get 3,450 divided by 300 times p becomes the square root of 300 times 2. So I get the square root of 600. Now I just entered that into my calculator, and I took that and I got the 140.846 answer when I did that. If Achieve wants an exact answer, which that's no problem in this case, you know that square root of 600 could be broken down into square root of 6 times the square root of 100, and we know that the square root of 100 is 10, so if I just divide the numerator by a factor of 10, I get 345 over the root of 6, and I think that would be the final answer that Achieve would want for that problem. No need to rationalize, remember. The unrationalized answer is actually better than a rationalized answer in a case like this, and the units are already provided on Achieve, so you don't have to worry about that. Okay, I hope that helps with number 22 in section 3.7. Again, the key to that problem was you couldn't take the derivative with respect to p unless you didn't first get your function in terms of p. And then once you did that, the derivative process was not bad at all.